inserts, for example, just because it's what we use over there, 2 centimeters from the joint. So the 2 centimeters goes right here. How much force must the biceps produce to balance that?
Okay.
So this is the full problem that you'd be given.
Uh-huh.
What you need to know, and it's that conceptual relationship I was starting to talk with you about, brother, is that the two torques, there's torques on one side and there's torque on the other. If you're talking about maintaining a position, you need to know that those two torques, in this case, are equal. The torque of the bicep and the torque of the arm. The torque of the bicep is the force of the bicep times the moment arm of the bicep, which then equal to the force of the arm times the moment arm of the arm. You with me? I'm just going step by step. Some of this stuff in here you know, and some of it you don't. I don't know either moment arm here.
Yes, you did. You said it's 20 centimeters.
I said the weight is centered.
Oh, the weight is
20
centered.
centimeters.
Okay.
Remember the moment arm for each of these, and this is, I can go either way, but the moment arm
It's
is
a
the perpendicular
perpendicular
distance from the
Okay.
line of force to the axis. So this is the moment arm for the bicep, and this big one is the moment arm for the arm. So basically, I'm not given these two things, so I need to solve for them and then plug them back in, because this is the only unknown. Because in the question I said, how much force must the biceps produce?
Oh, and if you said force for the arm, we'd be looking for this,
Yeah, which you're given.
which
so
we're
you don't
giving.
need to.
Oh, because it's
This is
the
the only thing in the problem you're given that you can put in here. Everything else you have to solve for.
My bad. And how did you word this again?
So I said the weight of the arm and a weight you're holding is 50 newtons, and it's centered this distance from the axis.
So the 50 newtons is the force of the arm. Okay.
And then what you need to do is just make two triangles. Make one triangle.
2 centimeters.
Remember, if this is 40, what does this angle have to be?
Minus 90, 50.
Yeah. And I'm solving for this moment arm of the bicep, which is the cosine of 50. Yeah. This, what I just drew, is this little tiny thing right there.
Okay.
And then you can have another one that's the bigger
A
triangle,
better one to get to.
and that's 20 centimeters and 50 degrees to get the moment arm of the arm.
Why is that one 50? Oh, okay. Okay.
Either way, they're both 50.
Okay.
What I did is I'm using this triangle up here.
And when you use this triangle, you use the whole thing from here, here. That's why this
Yeah.
is 50 too.
Yeah.
Okay.
Either way, it's 50 for each. The triangle doesn't change. Just
Oh,
the
okay. Just
components.
a component. But I'm sorry.
No, it's okay.
So, but if that's the case, then what are you getting out of this?
Out of what? Sorry.
What are you getting out of this whole thing right here? Because
Well,
you said
once
we
you
already
do-
have the.
Once you do this, you're getting the moment arm of the arm. So once you do this big triangle, which is
Oh, that's
this
the
one,
moment arm. Okay.
This is the moment arm, the perpendicular
Yes.
distance.
Okay. You're right.
And remember, there's two ways you can do it. I'm going to run through how to do it here, and then I'll show you how else. And that was your question over there. This big one is the moment arm of the arm. So I'm going to do same thing. Cosine of 50 is equal to adjacent, the unknown, over the hypotenuse. So in other words, this times the cosine of 50 is that. It should be a small number. It should smaller than this. So it should be like 15 or something.
Okay. Fine.
You with me? I mean, you can get a calculator and figure it out. Or what you can do, as long as you're cool with what this looks like, and once again, it's cosine of 50 is equal to that over 20 centimeters. Solving for this gives you 20 centimeters times that equals that. To where I have this, I can just put in 20 times cosine 50. And I left out the unit so it fit.
Okay.
And then this is the same exact thing.
Same exact thing.
It's not 20, it's only 2.
Oh yeah. Okay. The moment arm of the bicep.
Not the moment arm, just where the bicep is inserts.
Yeah, but the bicep inserts. What does it stand for? The DTLA or the D? This.
Perpendicular distance.
Okay, perpendicular
Perpendicular distance
of the arm.
Of the arm.
Perpendicular
Distance
of the bicep. Okay. And after you solve for that, all you
And
do is just
then
plug
now
it
you
in.
know this.
50.
So you plug that in here. I'm just doing this so I don't have to rewrite it.
Yeah.
That was the force of the arm?
Yeah, that's the force of the arm.
Okay.
So now the force of the biceps is the unknown. That'll be the moment arm of the bicep. So this times that equals that times that. How do you get this by itself?
Divided by
Divide each
cosine.
side by
2 times the cosine of 50.
So I haven't even plugged in anything to a calculator. And then I could literally just plug this into a calculator,
Get the
enter,
answer.
and that's my answer here.
Oh, wow. It's not too hard.
So now that's just doing it this way, but all you need to know is I need to make a perpendicular line from the force to the axis. I can either do it the way I did it, which is just continuing the line of force, or I can continue the axis and then go to the force.
Will they give us the same answers?
That's what I was about to
Yeah, they'll give you the same exact answer whether you use this triangle
Or that
with
triangle.
50 degrees or this triangle
With 40
degrees.
Would you have to change
The trig
this up
function
here?
is
Or no?
no.
That was given.
Yeah. In this example down here, so this is for this. If I'm using this bottom example,
Oh, it's going to change the cosine.
then it changes.
Yeah.
Because this
Sine.
is 40,
Yeah.
it changes to sine.
Sine.
Fine.
That's still 2. This is for the bicep.
Okay, this is
And then
the only part that gets me. So I get everything. Everything that you said. The only part I'm kind of confused about is when you make this line with the force of 50 newtons, and you said we have to make this perpendicular line. Will we be given this line to make, or like you just created
it
it
depends. You'll either be given this diagram
with this like this with the
drawn
line?
With the line there.
Okay.
Or you'll be given a word problem. And then, like any word problem, you got to draw it, label it, list your variables, pick your equation, do all that step-by-step shit.
Does it matter the distance? Like, let's say we put this line and put it here, it wouldn't
No.
have made any difference.
As long as you know that the distance is what it is you're getting.
Oh, as long as we know this is 20
Yeah.
centimeters, and we
It
can just
doesn't
draw.
matter. You don't have to draw it to scale.
Okay, yeah. We
You
could
just have to draw it so that you have a general idea, label it correctly. The two big things would be where to put the 20, where to put the 2, where to put the 40.
Okay.
Specifically, most importantly, is where you would put